Okay, so first to plot the data on the graph, just block in the 3 columns with the numbers. We'll insert XY scatter plot. Just choose the option with the markers only. I'm now going to place trend lines, and we'll have Excel create the equation of the trend line. First up, series 1, and in more options for series 1, I scroll down to the bottom and display the equation on the chart. Exactly the same for series 2, highlight the numbers, add the trend line, go to more options, scrolling down, display equation on chart. So now you see we've got the 2 lines with the equation of the line of best fit for both sets of data. To go to chart design here, and in select data, change the name of series 1, and that would be my NaCl data. And series 2 is the magnesium data. And OK. Now I want to delete the other parts of the legend here, so we don't need labels for the trend lines, and we're displaying those results there. Now to label the chart and place axis labels, and of course the very important measurement units. So on the y-axis, of course, we're measuring conductivity, and the units are millisiemens per centimetre. And we have concentration on the x-axis, measured in percent. And typically that's grams per milliliter. Larger the graph. Note I can adjust the size of the various parts of the graph. I might choose to bring the legend up to the side here and possibly even display it across 2 lines. Will that happen? Okay. I'll change NaCl data just to NaCl. So back in chart design, you go to select data, choose the first one, edit, and I'll take the term data out. Okay, so there's my chart and the chart title. That's the data plotted and the equations of the lines calculated. Now to process the unknown samples, and we're actually going to calculate the value of the unknown samples directly from the equations of the line. Of course, these can be estimated by observing from the graph that's been drawn, as we did in the class exercise. However, we can use the power of algebra to get an exact value based on these calibration curves. So of course the relationship that we need is based on the equation of the line, y equals mx plus c. Now by transposition we can calculate x equals the y value minus the intercept, calculate that amount and then divide by the slope, and that gives me the exact x value for each of the unknown samples. Starting with the sodium chloride example here, it would be equals, open bracket, we measured 9.25, that is the y measurement, subtract the intercept, all that in brackets because it belongs on the top of the fraction, and then divide by the slope. And that gives me a concentration of 0.50 measured to 2 significant figures. I've already formatted these cells so that they will display 2 decimal places. And once again, equals open bracket, it's my conductivity measurement. So subtract the intercept and divide by the slope. 8.79 for the sodium, for the magnesium chloride. And that gives me the our analytical result, if you like, for the unknown samples. These are, at the moment, are formatted to 2 decimal places, which is the required precision. Of course, the numbers themselves, you'll see as I add, contain significant residual, but best displayed with 2 significant figures like so. And that concludes the conductivity measurements activity.